SDK. We are the core maintainers of Cosmos DB JavaScript SDK. So for you today we have built a demo. So let's see. So this is actually a support application.
Share that screen, I think.
Okay.
All right. So actually, we built a support application or a chat application for City.js conference, and it's actually data from this conference-related data, so that if you have any questions related to this conference, you can just ask it. And yeah, okay. So what do you want to ask first, Manik?
Sure. So since we are talking about AI, let's say who all are, what all talks are about AI.
We actually wanted to find our peers for this. Okay, it's taking some time. We'll blame it on the Wi-Fi. Okay, so what do we have?
Oh, so apart from Aman, there are two more speakers, Pradeepa and Ayush. Hey, Pradeepa and Ayush.
Good to see fellow AI enthusiasts with us.
Okay, so let's see what's the schedule of day 2. Or maybe so yeah, this is the schedule of day 2, and yeah, we do have a workshop also tomorrow. So
this was actually a bit of a self-disclaimer that please be there tomorrow also. We prompted this question just so that you guys are also available tomorrow.
Okay, and let's ask one more question. Maybe something very simple, like when is lunch?
This is more of a personal question because we didn't have breakfast. So, okay, 12:40 to
12:40.
So yeah.
Yeah. So now Aman would talk about like how exactly we build this application. He is going to peer us through it. Like he is going to tell you. So
thanks, Manik. We can play around with the demo. I think till lunch, but let's because of constraint of time, let's start with the talk. So how do we build a AI application? So in total, like you require 3 major components for that. One being the chat or embedding model. Like if you want to talk to an AI model, you need an AI model, right? Then you need some kind of vector database so that you can store all your vector embeddings and all the knowledge base that you require for that application. And third is that once you have your AI models and you have a vector database, how do you interact with those? So for that, we need some kind of framework. So, and there are a lot more things like how do we deploy it and how do we maintain it and is it live or not. But due to constraint of time, we'll be focusing more on the vector database and the AI frameworks that we can use for these. All right, so many of you must have heard about Cosmos DB. I hope, but if not, so Cosmos DB is an offering by Azure, a database offering by Azure, and it has many different flavorings. Like we have Azure Cosmos DB for NoSQL, we have MongoDB API, and in this presentation we'll be focusing more on the NoSQL part. So Azure Cosmos DB NoSQL is so as you know, like if you want to use, it has different offerings like serverless. It provides provision throughput. If you want to scale it, like if you want to pay just for what you use, or if you want to do a configured, like just pay beforehand and use that. So you can choose between those two. If your application gets a lot more load instantly, you can configure dynamic and auto scaling. We provide low latency and very mission critical reliability. And shortly you will see some of the ways this is actually getting used in the live part. All right. So you must be thinking, okay, Cosmos DB, I was talking about like we need a vector store, right? But and I was talking about like Cosmos DB being a NoSQL API. So that is just not it. Cosmos DB actually is works as a vector store too. You can actually in the Cosmos DB you can store the vectors and the data for which you generated those vectors in a single document, and that actually reduces a lot of the complexity. So for example, you don't need to maintain two databases, one for the text that you create and other for the vectors that maintain it. If you put those all together in one single document, what happens is that it greatly reduces your operational complexity. You don't need to maintain sync between two databases. And actually, like in real world applications, that is a huge overhead to keep those two data in syncs. You can always be assured that your data is always with the right vector. And then apart from that, if you want to do a subset query on a very small specific subset of your vector database, because like vector search in general are very expensive tasks. So if you are able to narrow down your search in that vector database, that is actually a huge cost benefit. And with Cosmos DB, what you can do is like with the already existing SQL query language that we have, there is an option to very specify subset of that, like where you want to query that data, and that is actually a great feature. Then there are different indexing policies like flat, quantized, flat, and disk ANN, and that is actually, that helps you query your data very efficient. And then once you combine all of this with the Cosmos DB actual all its own capabilities, you can get a very good vector search data store. All right, so some of the actual use cases where Cosmos DB is getting used and why we chose to use it in our application. So anyone wants to take a guess? Okay, most of you must have used ChatGPT, right? Right. So do you know which database is actually getting used there to store all your chat history? Yeah, MongoDB or Cosmos DB? It's Cosmos DB actually.
It's Cosmos.
So it's actually Cosmos DB. So you must have seen all your charts on the left side, right? Like you can go back to that chart and use continue conversation to at a particular point from that point onwards. So all that conversational context and all that history is actually getting used in the Cosmos DB. And OpenAI chose Cosmos DB because of its reliability and its scalability. So then the next comes is RAG. In a very brief talk about RAG. So we'll dive deep into this later, I promise. RAG is retrieval and augmentation generation, and this is actually the pattern that we use to build that chat support application that we were talking about. And so it is mostly about getting the right data out of the database at the right time and provide it to the generator or the LLM model. And the third being the semantic cache. So I think you must have seen that, okay, it was taking some time to load up the answer at that point of time, right? Like when we asked it, when is the lunch? It took some time, or when what all people are talking about, but which all speakers are on AI, talking about AI. You saw that it was taking some time. So actually vector search can help that thing. A good vector store can help with that thing, because like if someone has already asked that question, and if someone already got that answer, what you can do is like you can cache that question as a vector and store that corresponding text along with it, so that next time if a person asks that same question, you can get that result straight ahead instead of getting into all the latency that is involved with the LLM model. Yeah. So I think, yeah, you saw the title, okay, why are we not talking about JavaScript? As we mentioned that we are the maintainers of JavaScript SDK. So yeah, we are the maintainers of JavaScript SDK, and it's actually by the name of Azure Cosmos, and we are getting almost 500,000 downloads every week for this. So the best part about this SDK is that it's fully open source. If you want, anyone wants to see the code, they can do that. If they want to open a bug or contribute to that or request a feature, we are always open to that thing. Then talking about some of the benefits of our SDK is that it actually follows fluent API design. It has enhanced security and compliance, and actually supports all the modern TypeScript and JavaScript features. So if anyone wants to go have a look at that, they can check it out on the NPM, or reach out us on our booth outside, and we'll be happy to talk more about it. Yeah. All right, so now that we have our embedding model sorted, like we actually were using Azure OpenAI embedding models and the chat models, and we talked about the vector database. So now we require something that we will be able to communicate with them, both of them very easily. So that is where some of the famous open source JavaScript AI frameworks come into picture. Some of the example being the langchain and the llamaIndex. So you might have heard of these related to Python. So actually, langchain JS and llamaIndex TS are the sister projects of the original ones. And they were made because of the huge demand in JavaScript community that because JavaScript being such a good language to build AI applications, so these are getting hugely popular nowadays, and they are actually open source projects. So if anyone wants to contribute to them, they can do that. So the benefit that they provide is that they provide very highly abstracted components. So what are the things that you require to build such an AI application? You require chat models, embedding models, vector store, data store, and all these things, right? So, the benefit of these platforms is that they provide very high-level abstraction on top of them. It's mostly like plug and play. If you don't like one vector store or one chart model, you can simply swap it with the other one, and it's just a one-line code change. And we'll shortly see.
Yeah,
see
we will
that
see it in the code box.
In the demo, right? Yeah. In the code, yeah. And you actually what I already talked about, like you build a chain of these components, and you can see all that into picture. Yeah. So now I think we are done. We know all the three components. Now let's see how we can connect all these three components. So RAG consists of two components, and RAG stands for Retrieval Augmented Generation. And two components, the retriever and the generator. So retriever, the main work of retriever is to actually retrieve sensible knowledge out of the vector database. So like the vector database returns you all that knowledge, but the request to that vector store is actually sent to the from the retriever. And all that sensible information that you get back from the vector store along with the original question, you augment it into the prompt that is to be sent into the generator or your LLM model. So this is actually RAG. So now let's see, okay, how we converted the database, how we actually made the database and converted that into the vector store for this, specifically for this conference. So, but all we did was like so it's just a one-page PDF, right? It's just a one-page PDF that we took related to the, okay, what are the timings and who all are the speakers and what they are talking about. I think it was, yeah, mostly one-page PDF only. We just gave it to the langchain. It read all that data, and it read all that text. It passed that to the embedding model to convert embeddings out of it. And yeah. And then we stored that embeddings. Embeddings are basically like your meaning. If you have any data, embeddings actually store the semantics or the meanings of that data instead of just like these that array that you see. It might just seem a high-dimensional vector array to you, but it's actually knowledge for the data for the LLM model. And then you combine both of these and actually store that into your database to be retrieved at the right time. So this is like how you get your knowledge base for that application. All right, now. So what we did, like just an overview of how this application was actually built. So the user, or in this case, Manik, who actually prompted the question, question or like when is the lunch, that got sent to the retriever. And that retriever actually sent that question, like when is the lunch, to the embedding model to convert embeddings from that. And then embedding model actually return you back the embedding for that question. And then that, when is the lunch in the vectorized form got sent to the vector database. Okay, it understood, okay, what needs to be searched, it performed a vector search, and then it returned that back to the retriever. Now, at this point, you have your vectorized embeddings and your relevant docs and actually the original text question also, right? So now that you have your original text question, when is the lunch, and the relevant answer from the database that, okay, in some of the line it had mentioned that, okay, the lunch would be at 12:40 to 1:40, right? So all those two combined are augmented into the prompt and actually sent to your LLM or your chat model. And it generates, based on that, it generates the answer. And it returns that back to the user or Manik, and we all got to know that, okay, the lunch was at 12:40. Yeah, so that is how RAG works. And we'll quickly show, give you a quick code walkthrough that, okay, how in like 40, 50 lines you can actually build this kind of application. I'll hand it over to Manik now.
Sure. I wanted to show the entire application, but in interest of time, oops, give me a second.
Yeah, we'll blame this to Murphy's law, I think.
By the way, like we have open sourced this repo, so anyone can try it out. So you have to just put your enterprise data, and in the README you can see simple steps like how to configure it, and you can make a chatbot for your enterprise too, or your projects if you want to do something.
Still taking time.
Internet is a bit slow. Slowly.
Hotspot?
Yeah.
All right, I think let's try it for 20 seconds more, or we can show from the GitHub repo actually. Not the docs. Yeah, sorry about the delay. Yeah.
So this is, so we would be only talking about the chat API, which the UI which we presented was using. So it would take in your chat as request, and as Aman has already talked about, we need three things. An embedding model, so we are using ADA here, and a generation model, which we use GPT-4, and a vector store, which was Cosmos DB in this case. So this is mostly about creating, just initializing the model. You can play with these OpenAI settings too for context. And then we created a chain. We called it as RAG chain, which like combines the prompt, the question which was asked in chat, along with the documents which were retrieved from the vector store. So in this retrieve, so currently retriever is configured to fetch top 3 documents, like top 3 relevant documents. So it fetches that and feeds to generation model, or LLM in this case, and then we just wait for the response, and then convert it into JSON object and send it back. So you can see in just 40-15 lines of code you can create your own chatbot. So
yeah, and the configurable the one-line code change that we were talking about. For example, if you don't like your llama embeddings model, then what you can do is, like, for example, line number 66 that you can see, you can simply replace it with the model of your choice. And let's show them quickly the data store that we configured in Cosmos DB. Yeah, Manik, can you zoom into it?
Yeah, thanks for pointing it out.
Yeah.
Is it fine?
Yeah. So, for example, the way we are able to use Cosmos DB into this is we have actually integrated or provided wrapper of Cosmos DB into the llama into the langchain library, and you can actually use Cosmos DB this way. Like Cosmos, you just need, this is just like a one-line change, line number 62. If you don't like Cosmos DB, you can use something else of your own. And this is like how that swappable components are built, and you can just create a chain out of it and just use it. So yeah. Right. Yeah. Thanks everyone. Thanks for bearing us, and just as a get-go, lunch is at 12:40.
If you have questions, you can scan this QR code.
Will be reachable at the booth also. Yeah. Link of the which one? Azure SDK?
Langchain.